Welcome back everyone, and before I go into what I have planned for this video, I just want to clarify one small point. So if you've played around with star UML, you would have seen that in star UML the an interface is shown like this, and in some cases you might have seen something like this for an interface as well. So it's just like a class, except that it also has a stereotype here. So within double angular brackets we have interface written here. So this is another representation of an interface that you might have seen. So what's going on here is that this one right here is the UML representation, and this one right here is the OMT representation, and OMT stands for object modeling technique. So this object modeling technique, and the object modeling technique uh, is a predecessor of UML. So UML comes from OMT. So don't worry about it. This is just an old representation of an interface. This one right here is what we are going to be using. So this is the UML representation, but in case you see an OMT representation, don't freak out or anything. So now let's go into what I have planned for this video. Um, since we have looked at composition, let's look at an example where we could use both inheritance and composition. Let's look at the window example that I think I've mentioned earlier. So let's say I have a window of an operating system. What I just want to point out, this is the computer window. So this window right here could be a rectangle, or it could have a rectangle as its body. And the difference between these two is that if a window is a rectangle, then it would have to inherit from the rectangle class, whereas if a window has a rectangle, it'll have an instance of the rectangle class and use that instance as its body. So using both inheritance or composition here are correct, but I just want to look at the key differences between inheritance and composition, a few pros and cons, so that we are able to decide which one to use in which case. So the first very important thing about inheritance is that it's simple to use. So most languages have built-in support for inheritance. They have something like the extends keyword, and it's explicitly seen in the code. Whereas composition is a little tougher to use. So that's one point. Another very important point is that inheritance is white box, and composition is black box. So this is a very important point, and what white box or black box means that in inheritance we write the implementation of any operation in a subclass based on the implementation that the parent class has. So we may want to override a method, we may want to leave it as it is in the parent class. So in case of inheritance, we would have to know the implementation of the parent class. So inheritance makes the implementation visible, whereas in case of a composition, as long as we know what the class that we've used an instance of can do, we are fine with it. So we just need like a signature for the method as to how to call that method, what kind of return it gives, etc. So if we want to take a look at the window example right here, in case of composition, if we have a resize operation for a rectangle, we don't need to know how it does the resizing, but we just need to know what we need to pass. For example, we may need to pass the new width and height, and so on. So that's inheritance and composition. And in this sense, it some people also say that inheritance breaks encapsulation. So, as far as the subclass is concerned, the parent class has broken its inheritance for the subclass or the child class. So, that's as far as object-oriented programming is concerned, that's not a very good practice. Uh, However, this white box and black box thing could be looked at as a pro or a con in favor of inheritance or against it, because sometimes knowing the implementation means that we could alter the implementation right away, and we don't really have to do the implementation again. So we are sticking to the don't repeat yourself principle. So, but in most cases, we don't want to give away our implementation. We want to keep our implementation hidden. So, in that case, it becomes something against inheritance. So, that's one thing. And the second thing about inheritance and composition is that inheritance is static or compile time, whereas composition is dynamic. So it's runtime. What I mean by this is that in inheritance we're giving away what the relationship between two classes is before the code runs itself. So that can be changed while the code is running. We've specified the relationship in the code itself, and that can't be changed. Whereas in case of composition, there's a lot of runtime freedom that we get. For example, let's say we had a vehicle class, a car class, and a bicycle class. And say we have a class which composes of vehicles, or which just has an instance of the vehicle class. So what would happen there is that we would have vehicle v1, vehicle v2, and so on. So v1 could first hold a car, and later we could during runtime itself we could change v1 and make it hold a bicycle, because after all v1 is v1 is of type vehicle, so it can hold any class that is a subclass of the vehicle class. So in that sense, inheritance is static and composition is dynamic. Another thing about inheritance, and now this is slightly specific to Java. So Java only lets us inherit one class, and that class should not be a final class. I talked about the final keyword a few videos ago, if you remember. So a final class is one that cannot be inherited. So uh, there are some constraints in Java which say that you can only inherit one class, and that class cannot be a final class. Whereas in case of composition, that's there are no such constraints as such. So we could have an instance of a final class as well in another class, and there's no limit on what number of different classes I can have instances of. So I could have inside some class, I could have an instance of a rectangle, an instance of a circle, an instance of some other shape, let's say a hexagon or something like that, and there's no limit as such. So let's take a look at this through an example. So this window class that we looked at, say everything in our operating system is a widget, and this window class would then have to inherit from the widget class, and in that case it cannot inherit from the rectangle class, because there's only one inheritance allowed. So in that case we would have to make a rectangle as an instance of the window class, so that would become a case of composition. So these are the key differences and the pros and cons of inheritance and composition. And here's a principle, a very very important principle I would say, that I happen to read in a book. So it says prefer composition over class inheritance. So this is a very very important principle. So given a choice, as long as inheritance is not obviously what fits better, we should always go with composition. Another last thing that I want to mention is that composition basically means that we could take smaller parts and make an object from these smaller parts by putting together instances of these smaller classes. For example, we could make a bicycle by say having two instances of wheel classes, one instance of say a gear class or something like that, and maybe an instance of a bell class or something. I don't know what other classes you might have that you can use to make up a bicycle, but composition basically refers to using smaller classes and getting them together to make up a bigger class. And inheritance is kind of the other way around. So smaller classes usually inherit from a more general class. So that's the last thing that I wanted to mention. So this is it about inheritance versus composition. And next up, I think it's time we take a look at abstract classes and interfaces. So I think I'll cover that in the next video. So I'll see you there.